problem. Please avoid noise because I go putting off my microphone and stop the recording. Oh, I understand now. Okay, stay quiet or using the chat to communicate with me because stop recording, maybe. Okay. I have two video, no? Now I have two video. Well, okay, no problem. Okay, this is the square function, no? And the second step is a -2 inside can represent horizontal shift 2 units to the right. Makes sense, right? And +1 is 1 unit over vertical shift like that. This is my final answer. I suppose que es equivalent 100% with this, que es the original way to is giving the problem, no? Look at that. O sea, you see clear that the black one and the blue is equivalent. Do you see or no?
Yes.
Do you see? Excellent. Okay. Entonces, I suppose que in this moment you understand very well transformation. No? Very well, no, a little bit. I want to complicate a little bit. I bring this example que I call conclusion because you see, suppose we have a segment like that. Of course, it's a function. No it's a weird function, no, but it's a function que illustrate, at least for me, very, very well the transformation. Let me try. Look. I know when you adding plus something, and you're moving, for example, here, this is slider, you move positive is, wait. Include the endpoint. So we have typical vertical shift over, when it's negative is downward. No problem. Everyone understand very well this.
Yes.
I want to, my intention so far is summarize everything, condensing the idea. Now I want to move B. B create in the function B, get the transformed, a horizontal shift. Let's see, when it's positive, left, here. Sorry, left, and when it's negative is right. Do you see now? This is confusing for the student. The student believe it's opposite. No. Positive left, negative right. Do you see now?
Yes.
Now let's see the second kind of transformation. Okay, no B anymore. B 0. Now the multiplication. And now multiplication B by constant C. And a constant C is 1. But when you multiply by the number greater than 1, 2, 3, 4, 5, 1.5, create a vertical stretch. Look at that. Vertical stretch. Do you see that?
Yes.
Yes.
However, if you multiply by the number less than 1, suppose point something, 0.8, 0.5, 0.7, the transformation is a vertical compress. Make sense now?
Yes.
Yes.
However, if you put negative number, like a -1, que es a perfect reflection, -1, entonces es reflection about the x-axis, because the only thing I am doing is change the sign of the y. For example, that point gets to 2,2. Now, when you transform it, it's converting 2, -2. So the x value stays the same. However, the y value changes the sign. That produces reflection. What kind of reflection? Reflection across or about the x-axis. However, si I put -2, so it's a combination. It's reflection and stretching. Depending on the value, si es negative pero es less than 1, negative 0.3, so we have reflection and compress together. Clear?
Clear.
Now let's see next transformation. Okay, is let me try. This is one. Okay, cool. Suppose the next transformation is multiplication by d, ese factor, pero inside the parentheses. Let's see the effect. The effect is, si d is greater than 1, 2, 3, 4, 5, is horizontal because it's inside the parenthesis. You affect the x value horizontal. The motion is horizontal, but is compressed. Look, let me show you. Do you see compressed? The effect is like somebody pushing the green segment, pushing to the left and occur a compressing. Do you see that the y value stays the same, 5 and 2? However, the x value no, is reducing a division by d, and d is a number, 3.8. Suppose one elegant number, 4. Entonces 2 divided by 4, 1/2. And 4 divided by 4 is 1. Wow. Do you see the effect? So what is the technical name of this? The technical name of this is when the d is a factor inside the parenthesis greater than 1, the effect is horizontal compress. However, si d is less than 1, again I restore 1, the effect is horizontal stress. Do you see the effect?
Yes.
And if d is negative, exactly -1, ¿dónde estamos? But es pure reflection, pero reflection about the y-axis. Because you see the effect. The effect is the y value stays the same. Look, 2, 2, 5, 5. However, the x value is the same, absolute value, but opposite sign. Entonces, 2 is transformed in -2, and 4 is transformed in -4. Now, this idea is super clear. Super clear or super confusing?
Clear.
Clear. Okay, I create this animation because this is a little bit complicated to understand verbally, blah, 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 blah. However, if you see the motions, you see a picture, and this picture is also motion, it's easy to understand. Let's come back to the whiteboard. I bring two weird examples, very, very similar to the example that you can see in Alex. Do you see whiteboard?
Yes.
Yes.
Okay, cool. Let me try to here. Okay, cool. This is a rectangular coordinate. Look. Okay, that's it. Now, the new situation in this problem is, can you have the original basic function? Let me copy paste here. No. I copy several times. No, not necessary. See, yeah, it's necessary. Okay, two. What's that? This is no, I need 3 to understand much better. Okay, cool. We put together. It's a typical Alex problem. It's confusing for the students. Okay, we have the basic. We have the basic function. The name of this is G. And this is the basic case given in the problem. I need to investigate transformation. Okay, so now the basic is not given, unfortunately, like a function that you can manipulate completely square. No. It's graphically. So suppose that we have 3 points, 0, 0. We have negative 2, negative 4, negative 2, negative 4 here. And we have negative 4, 0 here. And we're connecting this and form a triangle. This is my function. So the point is 0, 0. The point is negative 4, 0. And the other point is negative 2, negative 4. Because day one, you are doing this transformation. Look, suppose that we are doing, so this is y equal, this is the basic, but I need y equal g minus x minus 1. Wow, what the hell is that? Well, transformation. So now you are doing transformation step by step. That is the reason okay, I put 3 rectangular coordinate system graphic. According to the order of operation, we are doing first this part. You are doing the graph of g, y equal g and minus x. So I am doing this. I need to recognize that this is reflection. Yes or no?
Yes.
What kind? Reflection about the x-axis or the y-axis?
Is it the y-axis?
Exactly. You need to remember that when it's inside the parenthesis, it's about the y-axis. So any point, it's easy, not necessarily thinking too much, because any point, let me use in green color, any point, we can transform it. Look, 0, 0, stay the same. Because when you change 0 for negative 0, negative 0 have no sense, it stays 0, 0. However, this point is negative 2, negative 4 is transformed like a positive 2, negative 4. Positive 2, negative 4. So this transformation change the sign of the x value. It's basically change the sign. And this point, the x is negative 2. Now, when you transform it, it's positive 2. And the y value stays the same. Now, this is 4, 0. It is. Now, when you transform it, this is 4, 0. My new function after the first transformation is this, is look like that. And make sense because the y-axis behave like a mirror. And after the transformation is the image in the other side, on the right hand side. So far, everyone following?
Yes.
Yes.
Excellent. Now, I'm using another color, minus 1. Oh, minus 1 is easy because minus 1 is vertical shift 1 unit down, no? So that part is a vertical shift 1 unit down because actually is negative 1. Now, point by point, you subtracting, you is going down because it's negative 1 unit in the y component. And the y component, for example, the origin gets 0, 0 would be 0, negative 1. 0, negative 1. This guy would be 2, negative 5 because the action is you subtracting 1 only in the y component and the x component stay the same, doesn't change. 2, negative 5. 2, negative 5. Here. 2, negative 5. And the last one is 4, negative 1. 4, negative 1 is this. This point is 2 comma negative 5, and this point is 4 comma negative 1. And this is the final answer after both transformations. Transformation number 1 was reflection. And transformation number 2 was vertical shift. One unit down. Cool? Everyone follow me? This is a typical problem in analysis, guys. Alex confusing, Alex give me a graph and you transform. It's obvious that the transformation happens in every point of the function. However, you take a reference point. What is the reference point? The reference point is the end point. You take this, and you take this, and you apply transformation, and the rest, I suppose, is the same. Let's do it one more. Let's do one more typical of this. Okay, let me try again. In this case is again. Okay, 1, 2, and 3. Okay. One, two, three. Make it slow. The function is given is something like that. The name of the function is f of x. F of x is the basic. Okay, I need to transform it. Okay, we have 3 points, 0, 0. Oh, I like 0, 0. It's nice. 0, 0. We have another point is 4, 2. 4, 2 here. 4, 2. And we have another point is negative 2, 4. Negative 2, 4. Here. Negative 2, 4. Is our function look like that. This is my function. It's formed by segment line. Now I need to transform it. How? Well, the final answer I need is y equal 2 times